Hello everybody, welcome into another lesson. So today we are starting a unit on analytic geometry, and this unit of analytic geometry will be in the 2D coordinate plane. So we have 3 units left here in Precalculus, so roughly 3 to 4 more weeks will be in Precalculus. Probably about early August we'll start Calc 1. But this unit's all analytic geometry in 2D. We'll be doing conic sections. We'll also be doing polar coordinates, polar graphing, parametric things, all kinds of other stuff. That's really going to be pretty cool. The next unit will be 3D analytic geometry with 3D vectors and all kinds of those type of things and graphing in 3D. Then the final unit's going to be limits, which will overlap with Calc 1. That'll also be the first unit of Calc 1. But today we're starting with our 2D analytic geometry. We're going to start the conic sections, and today's focus is on circles. Those are probably the easiest type of conic section to talk about, it's the circle. So you have the standard equation for a circle is going to be x minus h quantity squared plus y minus k quantity squared equals r squared, where the center of the circle are the coordinates hk. The radius is given by the quantity x minus h squared plus y minus k quantity squared and the square root of all that. Now, if your center is at the origin at 0, 0, then your equation of the circle gets to be real easy. You'll just have x squared plus y squared equals r squared, where your radius is the square root of the quantity x squared plus y squared. In this case, I have drawn a circle, and pardon my drawing, I'm not the best at drawing, in case you haven't figured that out. I'm not Bob Ross. I'm not great at drawing. But I have a circle with a center at the origin at 0, 0 and a radius of 5. And I have x-intercepts at 5, 0, negative 5, 0, and then y-intercepts at 0, 5, 0, negative 5. That gives me a radius of 5. When we think about a circle, it's the set of all points in the two-dimensional coordinate plane that are equidistant from a fixed point called the center. So I could take any distance from the center, draw to any point on the circle, they'll all be the same distance with that radius of 5. Because the radius connects the center to any point on the circle. Now when we get into parabolas, which are next, then ellipses, then hyperbolas, it's not quite as simple, but circles are probably the easiest to deal with. But what we're going to do today, we're going to first start out given an equation of a circle. From that, we're going to identify the center and the radius. We're also going to identify the x and y intercepts. You really need those to draw an accurate circle. Then once you have that, we're going to graph the circle. So let's go ahead and get started here with some examples. Alright, so let's say here, I'm going to start with a couple with the center at the origin. Do a few of those. Let's say I have x squared plus y squared is equal to 49. So I've been given x squared plus y squared equals 49. First thing you probably want to do is identify your center. Well, you can think of that x squared really as x minus 0 quantity squared, right? Because anything minus 0 is itself. So we know the x coordinate of the center is going to be at 0. And the y coordinate, that y squared, you can largely think of that as y minus 0 quantity squared. So the center is truly at 0, 0. Now the radius, well, this is the radius squared to the right of the equal sign. Well, what's the square root of 49? That's just 7, right? So we have a radius of 7. So we've identified the center, we've identified the radius. Now, probably the next thing you want to do is go ahead, find your x and y intercepts. So you can find your x-intercepts when y is 0, right? So if you take x squared plus 0 squared, or just simply 0, you'll get that equal to 49. You get x squared equals 49, which would give you x equals both plus and minus 7. So your x-intercepts can be found both at plus and minus 7, 0. Why don't I go ahead and start plotting some of these? Here's my center at 0, 0. So the center is found at 0, 0. So let's see, x-intercepts 1, 2, 3, 4, 5, 6, 7. And then 1, 2, 3, 4, 5, 6, 7. Here's negative 7, 0. Let me write these down. So you have 7, 0. You have negative 7, 0. And then your y-intercepts are always found when x is 0. So you would just get 0 plus y squared is equal to 49. Well, that would just give you y squared equals 49, which means y would equal also plus and minus 7. So your y-intercepts will be at 0, plus and minus 7. Why don't we also plot the y-intercept? So 1, 2, 3, 4, 5, 6, 7. So here's the point 0, 7. Then we need to go to 0, negative 7. So 1, 2, 3, 4, 5, 6, 7. Alright, so there is 0, negative 7. The reason we want to find the intercepts is because that's going to help us draw a clear picture of the circle. Now that we know the radius, the center, and all the intercepts, we can go ahead and graph our circle. So let's just basically connect the dots. There's the first part of it. The second part, again, I'm not the best at drawing. I had a compass, but it doesn't like to stay on the board. But nonetheless, there is my circle with a radius of 7, the center at 0, 0 at the origin, and then my respective x and y intercepts that form the circle. So that's how you're going to graph a circle. Alright, let's go ahead and do another simple one at the origin. Alright, so we have x squared plus y squared equals 4. So we're going to do x squared plus y squared equals 4. Well, let's identify the center. So clearly this is x minus 0 squared and y minus 0 squared. So again, that puts the center right at the origin. Now the radius, well, the right-hand side's really the radius squared. The radius is always a positive length, so what's the positive square root of 4? That's just 2. So we'll end up with a radius of 2. And a trick to find the intercepts, you don't even got to put in 0 for x and y and solve. If you want to find your intercepts, take your radius length of 2, add and subtract 2 from each coordinate of your center. So if I want to find my x-intercepts, all I have to do is take then that 0 plus and minus 2, leave my y-coordinate alone, which would give me my x-intercepts both at plus and minus 2, 0. So why don't I go ahead and start plotting these intercepts. So here's 2, 0. Here's negative 2, 0. My y-intercepts, I can do the same thing to my y-coordinates. This time I'll leave my x-coordinate of 0 alone. I'll take my y-coordinate, add and subtract 2 of my radius from the y-coordinates, which would give me my y-intercepts at 0, plus, and minus 2. So why don't I go ahead and plot those? Here's going to be 0, negative 2, and then here's going to be 0, positive 2. And then obviously I have my center here at 0, 0. Now that I've got my center and all my intercepts and I know my radius, let's go ahead and plot. Let's go ahead and draw this circle. Just connect your dots and you'll have your circle. This time I have a much smaller circle, but still the center is at the origin, and then I have my respective intercepts. My radius is 2. So there is my circle that's been graphed based on this equation. Alright, let's do a few more where they don't give you the circle in standard form. What if I had something like this? I had something like 1/9 x squared plus 1/9 y squared is equal to 1. What if I had something like that? Well, in order for the equation to be in standard form, the coefficients on both the x squared and y squared terms have to be 1. So in other words, I need to multiply both sides by 9 to get rid of that denominator. If I do that, this is going to simply turn into x squared plus y squared is equal to 9 if we multiply both sides by 9. Now we have a form for the circle that we can work with. And again, the center is going to be at 0, 0. That should be pretty plain to see. Alright, and then my radius, if I take the square root of 9, my radius has a length of 3. Now, the intercepts, if I want to find my x-intercepts, I'm just going to take that 3, add and subtract that from my x-coordinate. So I should get x-intercepts at both plus and minus 3. My y-coordinate will still stay 0. So let's go ahead and plot those. Here is 3, 0. Here is negative 3, 0. And then my y-intercepts, this time I'll leave my x-coordinate of 0 alone. That stays the same, but if I take 3 and add and subtract that from my y-coordinate of 0, I'll get plus and minus 3 for my y-coordinates. So now, let's see, let's plot the y-intercepts. Here is going to be 0, 3. Down here is going to be 0, negative 3. Alright, and let's go ahead and plot the center at 0, 0. There's my center at 0, 0. I have enough now to go ahead and graph this. So let's go ahead and connect the dots. And there's my circle with radius of 3, with center at 0, 0. So a big takeaway from equations like this is that you need to get the equation into standard form where you have both a positive x squared and y squared on one side with coefficients on both of those as 1. Alright. Also, let's say I have something like this. What if I gave you an equation like this? X squared equals 16 minus y squared. You may also see something like that. X squared equals 16 minus y squared. Well, again, you need to get your x squared and y squared terms on the same side. They both have a coefficient of 1, so that's working in our favor. But in order to get those two terms on the same side, we need to add y squared to both sides. So if we do that, on the left side, you'll get x squared plus y squared would equal, the y squared would be gone on the right hand side, that would just equal 16. Now we have a form we can actually work with for the equation of a circle. So the center, again, should be obvious, it's at 0, 0. And then the radius, square root of 16, that just gives you a radius of 4. So we have a circle with center 0, 0, radius of 4. Okay, so let's go ahead and find our intercepts. X-intercept, if I just take that 0, add and subtract 4, I'll end up getting plus and minus 4, and then my y-coordinate stays 0. Let's go ahead and plot those points. Here is 4, 0. Over here is negative 4, 0. Let's also find the y-intercepts. Alright, so the y-intercepts are going to be found at, if I leave my x-coordinate of 0 alone, then I take my y-coordinate of 0, add and subtract 4 to that, I'll get 0 plus and minus 4. So let's go ahead and label my y-intercepts. Here is 0, negative 4, that's one of them. Then we need to find 0, positive 4, which is right here. And let's label the center being 0, 0. Here's my center 0, 0. Now that I have all the intercepts, I have enough to graph this. So let's see here. And one more loop of the circle, and there you go. There's my circle with radius of 4, center at 0, 0, with the respective intercepts. So again, it's just simply, no matter what equation you're given, you need to get the x squared and y squared terms on the same side with coefficients on both being 1. That's how you get the standard equation of a circle. From there you can get the center and the radius, and you can calculate your intercepts and all that. So those have been with the center at the origin. Now some of the next examples we're about to do are where the center is not at the origin. So let's change it a bit here. For example, let's say we have something like x plus 2 squared plus y minus 6 squared is equal to 16. Alright, so this just changed. We have the quantity of x plus 2 squared plus y minus 6 quantity squared equals 16. So, if we remember from the beginning of this video, the center is at HK. The standard form was x minus h squared plus y minus k squared. So, x minus h squared, this would end up, if we just take this and we set x plus 2 equal to 0, well, the center is at x equals h. So if I take that x plus 2, set it equal to 0, I would get that x equals negative 2, right? And then if I take that y minus 6, set that equal to 0, I would get that y equals 6. What does that mean? That means my center of the circle is actually at negative 2, 6. So I have a center at negative 2, 6. So here's negative 2, 1, 2, 3, 4, 5, 6. So here's my center at negative 2, 6. Now, what about, let's see, next thing we need to know is the radius. Well, the square root of 16 is 4. I still have a radius of 4. That's going to help. And let's see now, sometimes you're not always going to have an intercept depending upon your radius. I think it's very clear to see we're for sure going to have a y-intercept, but we may not have an x-intercept. It depends on the radius. So what I'm going to suggest is we still need to find 4 other points. We need at least 4 points to be able to draw a complete circle, if that makes sense. So let's go ahead, take your center. If you want to find, you need to find 2 varied x points and 2 varied y points. So let's say I take that negative 2 of my center, and then I also need to add and subtract that radius of 4 to affect my x coordinates, but I'm going to leave my y coordinate of 6 alone. That's going to translate into, if I take negative 2 minus 4, that would give me the point negative 6, 6. If I take negative 2 plus 4, that would give me the point of positive 2, 6. So we can plot those. So this is negative 2, 6, so negative 3, negative 4, negative 5, negative 6. So there's my point negative 6, 6. Now, let's find 2, 6 also. Alright, so here's 1, 2. Here's my point, positive 2, 6. You just really want to find 4 other points that this circle passes through from the center. You know, when the center was 0, 0, you always had x and y intercepts. Well, if your center is anything other than the origin, that may not always be true. It's going to vary, but still the moral of the story is find 4 other points to connect the dots. Now, if we want to affect the y coordinates, we're going to leave our x coordinate of negative 2 alone, but we're going to take that 6, we're going to take that radius of 4, we're going to add and subtract 4 from that. So you should get points of negative 2, and then if I take 6 minus 4, that'd be positive 2. Then if I take 6 plus 4, I should get 10. So I'd also have negative 2, 10. So negative 2, 2 is right here. Let's go ahead and label that. So you can clearly see we're not going to have any x-intercepts. We definitely have a y-intercept, but we're not going to have any x-intercepts. The negative 2, 10 is all the way up here. This is going to be the point negative 2, 10. Now that we have 4 points around the center, we have enough to graph this circle. So let's go ahead, let's complete the loop. Alright, so there is my circle with a radius of 4, with the center located at negative 2, 6, and the various 4 other points on the circle. So this is what graphing a circle with the center not at the origin looks like. Clearly there's no x-intercepts. It never touches the x-axis. It does touch the y-axis in a couple spots, and in theory we could find those if we really chose to, but I don't see a need to do all that. But if you needed to find those, of course you just plug in 0 for x and you would solve a quadratic equation for y. But we're not going to get that crazy. Let's do another simple one like this, and then we'll do a couple of other equations where we got to do a little more work. So, okay. We have x minus 1 quantity squared plus y squared is equal to 12. So we get x minus 1 squared plus y squared equals 12. Well, this is in standard form. Let's first find the center. If I take that x minus 1, set it equal to 0, I'll get an x-coordinate of 1. So the x-coordinate of the center is at 1. And then you just have y minus 0 squared. That puts my y-coordinate at 0. So my center is at 1, 0. Let's go ahead and label that. The center here is at 1, 0. Now, what's my radius? The radius really equals the square root of 12. Well, what's the square root of 12? That breaks down into the square root of 4 times 3. That gives me a radius of 2 times the square root of 3. All of a sudden, we have a radical radius, so you will have that more often than you think, too. Let's be honest. We need to find 4 other points on this circle. In this case, it looks like we should have both x and y intercepts, but really the moral of the story is we need to take that radius, add and subtract that from our x coordinates and from our y coordinates to get 4 points around the center. So first let's affect our x coordinates. Of course, those would be just 1 plus and minus 2 times the square root of 3, 0. My y-coordinates are going to be 1 and then plus and minus 2 times the square root of 3 if I take those from 0. So those are the 4 other points I need to find. Now, let's go ahead and find these points here. So let's take the 1 minus 2 times the square root of 3. So negative 2 times the square root of 3 plus 1 puts me at about negative 2.46. So that's going to put me about right there. So that point right there is 1 minus 2 times the square root of 3, 0. Let me write it a little bit further left. So here's 1 minus 2 times the square root of 3, 0. And then let's do 1 plus 2 times the square root of 3, 0. That puts me at about 4.46. Which is going to put me about right there. So right here is going to be 1 plus 2 times the square root of 3, 0. Now I need to find my y-coordinates. So let's take negative, so we're going to have 1 for our x. X will always be 1, but let's find the y-coordinate. What is negative 2 times the square root of 3? That'd be about negative 3.46, so 1, 2, 3, about right there. There is my coordinate of 1, negative 2 times the square root of 3. And then it'd be about positive 3.46 for my y-coordinate, so this would be my coordinate of 1, then 2 times the square root of 3. Now that I have those 4 points, we have enough to draw the circle. So there is my circle with center at 1, 0, radius of 2 times the square root of 3. based on finding those 4 additional points and finding my center and radius. Alright, let's do a couple of unconventional equations here. You're going to see what I mean by that in just a second. Let's say what if I give you something like this? So we're going to have x squared plus 4x plus y squared plus 4y minus 1 equals 0. Well, starting out, that doesn't look like the standard equation of a circle. And in theory, and actually this is not in standard form yet, you'd be correct, but I can confirm this is the equation of a circle. The dead giveaway is going to be both a positive 1 on the x and y squared terms, the x squared and y squared terms, but we need to get this into a form where we can easily identify the center and the radius. Okay, so what we want to do, I hope everyone remembers completing the square. That's exactly how you're going to have to approach this. You're going to have to complete the square for both the x and the y variables. So let's get rid of the 1 out of the left-hand side and move that over. So good news is we have the x and y terms grouped together. So if we take x squared plus 4x plus y squared plus 4y, we now have that equal to 1. We just got rid of the constant term out of the left side, moved it over to the right. Well, what you got to do now, complete the square for your x terms. So you'll have x squared plus 4x. Now half of 4 is 2. If you square that, you get plus 4. Now let's deal with also doing it for your y's. So you'll have y squared plus 4y. Alright, well half of 4 is 2. Square that, you also get 4. That's going to equal, you still have that 1, but what you do to one side, you do to the other. You got to take that plus 4, add that to the right-hand side. Okay, so this x quantity is going to simplify into x plus 2 quantity squared, plus your y quantity would also be y plus 2 quantity squared equals your right hand side. 1 plus 4 equals 9. Now would you look at that? We have the form of an equation of a circle in standard form we can actually work with now. Why don't we identify the center first? So the center, take that x plus 2, set that equal to 0, you get an x coordinate of -2. So the x coordinate's -2. Alright, so what about your y coordinate? Take that y plus 2, set it equal to 0, you also get a y coordinate of -2. So the center of this circle can be found at -2, -2. What about your radius? Well, that's the square root of the right-hand side. Square root of 9 is 3. So the radius of the circle is 3. Now it's not so bad. Here's going to be your center at -2, -2. Alright, let's go ahead and find that radius. Or let's find 4 other points. First, let's affect your x-coordinates. So I'm going to take that radius of 3, I'm going to both add and subtract 3 from my x-coordinate of -2. I'm going to leave my y-coordinate of -2 alone temporarily. That should give me y-coordinates, if I take -2 minus 3, that should give me -5, -2. As well as then if I take -2 plus 3, I should get +1, then -2. So let's plot those. 3, 4, 5. Here is going to be -5, -2. And then here is going to be +1, -2. So there's my affected x-coordinates. Now let's find some changes in the y. If I want to change my y-coordinates to be equidistant from the center, I'm going to leave my x-coordinate of -2 alone. I'll take that radius of 3, add and subtract that from my y-coordinate. Well, that'll give me coordinates of -2 for my x. -2 minus 3 is -5. And then another x-coordinate of -2, a y-coordinate of -2 plus 3 of +1. So let's plot -2, -5, 3, 4, 5. Here is -2, -5. And then -2, 1 is found up here. So here is -2, +1. Now that I got my 4 equidistant points from the center, I can draw the circle. So there is my circle at center, -2, -2, radius of 3, with those 4 points that we found to be on the circle. Now let's do another one where we have to complete the square. This is also good algebra review for completing the square. This is a very useful thing to maintain. So, let's see here. Another good one. Only we're going to spice it up a bit. What if I gave you something like 9x squared plus 9y squared plus 54x minus 36y plus 17 equals 0. Alright, so you have the equation 9x squared plus 9y squared plus 54x minus 36y plus 17 equals 0. Well, this is a clue that it's a circle right away because you have the same positive coefficients on the x squared and y squared terms. When we get into other types of conic sections, that'll vary. But if you have the same positive coefficients on x squared and y squared, right away you can spot a circle. Now, we're going to have to complete the square, but the first thing you want to do, get that constant term of 17 out of the left-hand side, move it over to the right. So this will turn into 9x squared plus 9y squared plus 54x minus 36y is equal to -17. Okay. If we're going to complete the square, we want to get our x and y terms grouped together. So let's rearrange some terms here. You'll have 9x squared plus 54x plus 9y squared minus 36y equals -17. Okay. Before you even try to complete the square, look at your common x terms and y terms. What can we factor out? Don't factor out the x. What constant term can you factor? What coefficient? In both cases, you could factor out a common 9, right? So you could factor out 9 from the x squared and 54x. You'll have 9 times that x squared plus 6x. And then from the y, you could factor out another positive 9. So you'd have 9 times the quantity of y squared minus 4y. All that's going to equal -17. Now's where the part about completing the square comes into play. So leave that 9 alone in the outside of the x part. So let's complete the square on x squared plus 6x. So x squared plus 6x, well, half of 6 is 3. If you square that, you get 9. So you have a plus 9 inside the x. Let's do the same thing for the y. Whoops, I forgot that 9 outside. That's going to make a huge difference. So you'll have 9 times, okay, y squared minus 4y. Well, half of negative 4 is negative 2. If you square the negative 2, you get plus 4. All that's going to equal that negative 17. Now, what you do to one side, you got to do to the other. I have to add 9 times 9 from the x. 9 times 9 is 81. Plus, I have to add that 9 times 4, which is also 36. So let's simplify this a bit. You'll have 9 times that x squared plus 6x plus 9 turns out to be x plus 3 quantity squared, plus that 9 times y squared minus 4y plus 4, it turns out to be 9 times y minus 2 quantity squared, is going to equal the right-hand side. So negative 17 plus 81, well, that's going to be 64 plus 36, that's 10. Oh, sorry, that's 100. That equals 100. Now, the only thing left to do to get this into standard form is to divide both sides by 9, because you need the coefficients on these x and y terms to be 1. So your final answer should end up being x plus 3 quantity squared plus y minus 2 quantity squared equals 100/9. That would be your final answer to get the standard equation of the circle. So I know that one was a bit of a doozy, but between going through the process to complete the square and factor out common terms, that's what you get. You'll get x plus 3 quantity squared plus y minus 2 quantity squared equals 100 divided by 9. Now we can find the center and the radius. So the center, the x-coordinate, I take that x plus 3, set it equal to 0, I'll get x equals negative 3. For the y-coordinate, if I take that y minus 2, set it equal to 0, I would just get y equals 2. So I have a center at negative 3, 2. So negative 3, 2, 1, 2, 3, 1, 2. Here's my center, which is located at negative 3, 2. All right. Now we need to find the radius. The radius, if I just take the square root of 100 divided by 9, I should get 10/3. I have a radius of 10/3, which is a little bit greater than 3. So we've got the center, we've got the radius, now we need to find 4 other points. Let's go ahead and affect the x-coordinates. I think we're good with the equation down here. Let me go ahead and erase all this. If you need the problem, if you need the steps, please feel free to rewind the video. But I'm going to make some room here. So let me rewrite this problem, rewrite that equation up here. We have x plus 3 squared plus y minus 2 quantity squared equals 100/9. All right, what I need to do now is find 4 other points, 2 equidistant from my x-coordinate and 2 equidistant from my y-coordinate. So if I take my x-coordinate of negative 3, I add and subtract that radius of 10/3, and I leave my y-coordinate of 2 alone, what am I going to get? Let's first subtract 10/3. Well, negative 3 is the same as negative 9/3 minus 10/3. That puts me at negative 19/3. Then my y-coordinate of 2. If I take that negative 9/3 and add 10/3, that gives me a positive 1/3 for my x-coordinate with a y-coordinate of 2. Let's go ahead and plot those. So negative 19/3 is the same thing as negative 6 1/3. So 4, 5, 6, there's about negative 6 1/3. So here's negative 19/3 2. And then I get positive 1/3 2, which is right about there. So there's positive 1/3 2. Now I also need to affect my y-coordinates. So this time I'll leave my x-coordinate of the center negative 3 alone. I'll take that 2 and I'll add and subtract that radius of 10/3 from that. Well, that's going to turn into what? I'll still have negative 3 for my x. Now 2 is the same as 6/3. If I take 6/3 and I subtract 10/3 from it, I'll get negative 4/3. And then if I take my next coordinate, so negative 3 for the x, if I take 6/3 and add 10/3 to it, I'll get 16/3 for my next y-coordinate. So let's plot these points, negative 3, negative 4/3. That's going to put me about negative 1 1/3 there. So here's negative 3, negative 4/3. And then negative 3 16/3, that's 5 1/3. So 3, 4, 5. There's that point. So negative 3 16/3. Now that I got my 4 points, I can plot this circle. I can draw it. So there is my circle with center at negative 3, 2 and radius of 10/3 with those various points that we have found. Alright, now let's work a little bit backwards here. So what we're going to do now is we're going to be given, for a couple of equations, the center and the radius. And then we're going to have to find the equation, and then we'll graph it. So in this case, they give us that the center is at the origin. They give you that the radius is equal to the square root of 18. How are we going to find an equation? And then we got to graph it. Well, the equation, of course, is always x minus h quantity squared plus y minus k quantity squared equals r squared. Well, good news is center is 0, 0, so literally you'll just have x squared plus y squared. And this radius of the square root of 18 helps, because if we just square the square root of 18, we get 18. So there's your equation that you're looking for. It would just be x squared plus y squared equals 18. Now we can graph this too. The center is at 0, 0. So that's going to help. There's your center. Now what about your radius? Well, we know the radius equals the square root of 18. How does that break down? That's the square root of 9 times 2, so that's 3 times the square root of 2. So now let's find 4 other points here from the center. So if I want to affect my x-coordinates, I'll just take 0 plus and minus 3 times the square root of 2, giving me plus and minus 3 times the square root of 2, and then 0 for my y. Why don't we go ahead and figure those out? So what the heck is 3 times the square root of 2? That's about 4.24. So negative 4.24. So let's see, 1, 2, 3, 4, 2, 3, 4, 2, 3, 4, 2, 3, 4, 2, 3, 4, 2, 3, 4, 2, 3, 4, 2, 3, 4, 2, 3, 4, 2, 3, 4, 2, 3, 4, 2, 3, 4, 2, 3, 4, 2, 3, 4, 2, 3, 4, 2, 3, 4, 2, 3, 4, 2, 3, 4, 2, 3, 4, 2, 3, 4, 2, 3, 4, 2, 3, 4, 2, 3, 4, 2, 3, 4, 2, 3, 4, 2, 3, 4, 2, 3, 4, 2, 3, 4, 2, 3, 4, 2, 3, 4, 2, 3, 4, 2, 3, 4, 2, 3, 4, 2, 3, 4, 2, 3, 4, 2, 3, 4, 2, 3, 4, 2, 3, 4, 2, 3, 4, 2, 3, 4, 2, 3, 4, 2, 3, 4, 2, 3, 4, So here is my negative 3 times the square root of 2, 0 right here. And then the same in the positive, so 1, 2, 3, 4. Here's my positive 3 times the square root of 2. And then 0. And then in the y, it's going to be the same. You'll just have 0 plus and minus 3 times the square root of 2. So that'd be about, again, 4.24. So 1, 2, 3, 4. This coordinate is 0, 3 times the square root of 2. Then we'll come down here, 1, 2, 3, 4. Here is 0, negative 3 times the square root of 2. So we got our center, we got our points. We can go ahead and graph this circle. So there's my circle with center 0, 0 with a radius of the square root of 18, and there's my equation for it. All right. Let's do another one like it. We have a center again at the origin, but the radius equals 4 times the square root of 2. Alright, so we have a center at the origin, radius 4 times the square root of 2. Well, the center is at the origin, so the equation is going to start out as x squared plus y squared. That equals your radius squared. What is 4 times the square root of 2? Squared. Well, 4 squared is 16 times the square root of 2 squared. That gives you 16 times 2, which is simply 32. So the equation you'd be looking for is x squared plus y squared equals 32. We know the center. Now we just need to find 4 other points to graph the circle. So here is 0, 0, our center. Now, those 4 other points will have plus and minus 4 times the square root of 2, 0, and then we'll also have 0, then plus and minus 4 times the square root of 2. So let's go ahead and plot those points. Alright, so 4 times the square root of 2, that's about 5.66, so 1, 2, 3, 4, 5, about right there. So there is 4 times the square root of 2, 0. In this direction, 1, 2, 3, 4, 5, about right there. So there's negative 4 times the square root of 2, 0. Up here, 1, 2, 3, 4, 5, about right there. So there is 0, 4 times the square root of 2. Down here, 1, 2, 3, 4, 5, about right there. Here is 0, negative 4 times the square root of 2. Now that we got all our points, we can go ahead and plot these. We can draw the circle. So we'll do that. We'll do that. Swing an arc this way. And go right there. All right. So here is our circle at 0, 0 with a radius of 4 times the square root of 2. Alright, now, what if you're given something like this? We're going to do a couple where you're given the center and then the diameter. So you have a center, in this case, of negative 3 -1, but you got the diameter instead of the radius. The diameter is 2 times the square root of 7. Well, this isn't as bad as you think, because what is the diameter? The diameter is twice the radius, right? Which means the radius is half the diameter. So that's just going to give you a radius. If we take half of 2 times the square root of 7, you just get a radius of the square root of 7. Now, your center's for the x coordinates at -3, so x equals -3, that means you would get x plus 3 quantities squared, right? So x plus 3 quantities squared for the x part of the equation. Your y coordinates at -1, well, y equals -1, so that would end up giving you y plus 1 squared equals your radius squared. Square root of 7 squared, well, that's just 7. So here is your equation for this standard form of the circle. And I think we're good on graphing for a minute. That's really how you find your equation. You'll have x plus 3 squared plus y plus 1 squared equals 7. All right, let's do another. We have a center located at 5, -6, and they give you that the diameter, so you have the diameter equals 4 times the square root of 3. Well, okay, again, the radius is half the diameter, so if we take half of 4 times the square root of 3, we get a radius of 2 times the square root of 3. Now, to find the equation, if your x-coordinate equals +5, that means then you're going to have x minus 5 quantities squared, plus, if your y-coordinate equals -6, that means you would have y plus 6 quantities squared, equal to that 2 times the square root of 3 quantities squared. Well, square root of 3 squared is 3 times 2 squared, which is 4, so 4 times 3 is 12. So the standard equation you should get is the quantity x minus 5 quantity squared plus y plus 6 quantity squared equals 12. Now let's change it again. You're given the center of the circle, but a point it passes through. So they give you that for this circle that the center is at 3, 7. A point on the circle is going to be 1, 0. In fact, why don't we graph this one? We know that the center is located at 3, 7, so 2, 3, 1, 2, 3, 4, 5, 6, 7. The center is all the way over here at 3, 7. A point on the circle is 1, 0. So what do we got to do here? The center is easy. We know the left side of the equation already. What we don't know is the radius. Well, isn't it true that the center of a circle is equidistant from any point on the circle, which would indicate the radius? So the radius in this case is going to equal the distance between the center and a point on the circle. So in this case, the radius is going to equal the square root of that point on the circle, your x point of 1, minus your x coordinate of the center, 3 quantity squared, plus your y-coordinate of the point on the circle of 0 minus your y-coordinate of the center squared, so minus 7 squared. Well, that means then that the radius is going to equal the square root of negative 2 quantity squared plus that negative 7 quantity squared, which means your radius equals the square root of 4 plus 49, which would just be the square root of 53. You end up with the square root of 53 as your radius. Now that we've identified the radius, we have the center, we can do the circle. So x equals 3 for the x-coordinate of the center. Well, that's going to end up being x minus 3 quantity squared plus, now you have y equals 7 for the coordinate of the center. That would be y minus 7 squared equals your radius squared. Well, square root of 53 squared just gives you 53. So there is going to end up being your equation of the circle. X minus 3 quantity squared plus y minus 7 quantity squared equals 53. I got one more like this. I just wanted to at least plot the points. We'll be given the center and a point on the circle again. All right. So we have the center located at 6, negative 3. So here's the center, 1, 2, 3, 4, 5, 6. So there's your center located at 6, negative 3. The point on the circle that they're indicating is going to be negative 2, 4, which is right here. That's going to be negative 2, 4. So as you see, we have a huge circle that won't even fit on this. But the center, the distance from the center to a point on the circle again is the radius. So we need to find the distance between those 2 points, which would be the radius. So you'll take the x-coordinate of the point on the circle, that negative 2 minus the radius coordinate of x, so negative 2 minus 6 squared plus, take your y-coordinate of 4 minus that negative 3, well, that would turn into 4 plus 3 quantity squared. So this would simplify into the radius equals the square root of negative 8 squared plus 7 squared, which means the radius equals the square root of 64 plus 49. Which means the radius is going to equal the square root of 113. And that's the best we can simplify that radical for the radius. So we now can form the equation of the circle. So if x equals 6 for my center, that means I'll have the quantity of x minus 6 squared plus, if y equals negative 3, that means I would have y plus 3 quantity squared equals my radius squared. Well, square root of 113 squared just gives me 113. So there is my standard equation of the circle. In this case, I'll have x minus 6 squared plus y plus 3 squared equals 113. All right. Well, you know what? There's something else I would like to do. There's something called the tangent line problem. So, what does tangent line mean? Again, if we think of it, a tangent line touches at one point. It only touches, it doesn't cross through. What do we remember from geometry about tangent lines to circles? They're always perpendicular to the circle at its radius. So we need to find the tangent line we want to find the tangent line to this circle at the point -2, 4. So we know the radius equals the square root of 113. Well, we should probably find the equation of this line. So we want to find the tangent line at the point -2, 4. Alright, so let me draw this brown here. We're going to have some tangent line. Let's pretend this circle is drawn. Okay. This would be too big to draw, but let's pretend this circle is drawn. In fact, let me try to draw this a little bit here. It's not going to be real exact, but that's roughly about what the circle is going to look like here. You have a tangent line that touches the circle at -2, 4. We want to find the equation of the tangent line at this point. Good news is circles are easy. The tangent line is always perpendicular to the radius, right? At its point of tangency. That's a theorem from geometry that's been a while. But what we need to do first is find the equation of the radius. How do we find the equation of a line? First, we need to find the slope of the line. So, the slope of the radius, in fact, we don't even actually need the radius. If we want to find the slope of the radius, so m sub r, that's going to equal y2 minus y1, so we can make that for our y2 at the point of tangency, 4 minus -3, which would be 4 plus 3, all over then our x2, which would be -2 minus our x1 of 6. Well, what does that give you? That would end up giving you 7 over -8, or simply -7/8. That's going to be the slope of this radius, right? What do we know about perpendicular lines to points? Perpendicular lines, they have a negative reciprocal slope. So that means the slope of the tangent line, we'll call that m sub t, is the negative reciprocal of that -7/8. That would be positive 8/7. Now, all we need to do to find the equation of the tangent line is take those points on the tangent line, which is -2, 4, and put those into the equation. So let's do this in point slope form. If I take y minus that y coordinate of 4, set that equal to my slope of 8/7 times x minus -2, or x plus 2. This would simplify into y minus 4 equals 8/7 x plus 16/7. So my final answer should be y equals 8/7 x. And then we have, well, 4 in terms of 7 is 28/7. So if I add 28/7 to 16/7, I should get 44/7. So my equation of the tangent line to the circle at the point -2, 4 is going to be y equals 8/7 x plus 44/7. And tangent line problems are huge in calculus. And that slope really is the rate of change, which also is known as a derivative in calculus. But we're not going to go that far just yet. But we're previewing it. Now let's go back to another problem here for the tangent line. So let's go back to another problem. Let's say we had that one where the center was at, what was it, 3,7? Yeah, the center is at 3,7. So 1, 2, 3, 4, 5, 6, 7. Here's my center at 3,7. The point on the circle was at 1, 0. So here is my point on the circle at 1, 0. Let's pretend, heck, that this circle's drawn. It's going to be another huge circle, but I'm just going to kind of wing it here. Not that bad, I'm not going to wing it. There's my best attempt at a circle. I'm sorry about that, but we want to find the equation of the tangent line to the circle at 1, 0, right? We want to find the equation of this line, that tangent line. Well, we know a tangent line touches a circle at one point. And if circles and tangent lines are perpendicular to each other at the point of tangency from the radius. Probably not the best representation, but these are perpendicular. So first thing you need to do again to approach this, to find the equation of this tangent line at 1, 0, find the equation of the line for your radius, or at least find the slope of that line for your radius. So let's take the slope of the radius. That's going to equal my y2 of 0 minus my y1 of 7 all over my x2 of 1 minus my x1 of -3, which would simplify into -7 over -2, or 7/2. So the slope of this radius line is going to be 7/2. That means the slope of my tangent line, if it's perpendicular to the circle, which is perpendicular to the radius, is the negative reciprocal of 7/2, which would be -2/7. So now I found the slope of my tangent line to be -2/7. All I have to do is take that point of 1, 0 on the tangent line and put it in point slope form. So y minus 0 would equal -2/7 times the quantity of x minus 1, which would simplify into y equals -2/7 x plus 2/7. That would be the equation of the tangent line at 1, 0 to the circle, with center at 3, 7 and the point on the circle being 1, 0. So the next lesson's going to be on parabolas. We'll even have some tangent line problems then. The problem is it's not quite as simple as doing it with a circle, but we'll still be able to do them. But we're going to talk in general about the conic sections of parabolas in the next lesson. So I hope everyone has a great day. Take care.